Hello, everyone. Welcome back to 360 on History. Please check out our website 360onhistory.com, our YouTube channel, and social media. And do not forget to check out our new book available on Amazon, and the link can also be found on the website. It's on fantastic women from science and history. Today, we are going to talk about the moon, our only satellite, known to us by many names such as Luna and Selene, which has fascinated us for all of our existence. We've looked up at it and wondered about its influence on us, and we've also thought long and hard about how it came to be. We now understand our moon's origin story. But let's start from the beginning. The moon orbits the Earth at an average distance of 384,400 kilometers, or 238,900 miles, which is about 30 times the diameter of Earth. Ever since it has been captured by Earth's gravity, it has been tidally locked. This means that the same side of the moon always faces the Earth. The tidal locking also means that the lunar day and the lunar month are the same length at 29.5 Earth days. Our moon also affects our tides along with the sun, which also has a minor influence on them. It is 1.2% the mass of the Earth, with a diameter of 3,474 kilometers or 2,159 miles. This is approximately 1/4 of Earth's. Our moon is the largest, most massive satellite in relation to its parent planet in the solar system. Overall, it is the fifth largest and most massive moon and is larger and more massive than all the known dwarf planets. It has a surface gravity of 1/6 of the Earth, approximately half of Mars. After Jupiter's moon Io, our moon's surface gravity is the second highest among all the moons in the solar system. Boasting a differentiated and terrestrial body, it has no significant hydrosphere, atmosphere, or magnetic field. The lunar surface is covered in dust and mountains and impact craters, which can be seen all over it, in addition to ray like streaks. So, all those shadows that you see when you look up at our moon at night, that's what they are. Plains of cooled magma called maria or seas are also visible on the near side, which is the side facing us. These maria or seas were formed when molten lava flowed into ancient impact basins. This brightest celestial object in our night sky is always illuminated by the light from the sun, of course, except during a lunar eclipse when it passes through the Earth's shadow. From Earth, about 59% of the lunar surface is visible over time due to cyclical shifts in perspective, which are known as libration. These make parts of the far side of the moon visible. So, like I said before, humans have always been fascinated with this bright object in the night sky. It has been a source of inspiration and knowledge. It has been crucial to increasing our understanding of the cosmos, of natural science, timekeeping, and spaceflight, but it has also played a huge part in our mythologies, religion, art, and poetry. We first made physical contact with it on September 13th, 1959, when the first human made object to reach an extraterrestrial body was the Soviet Union's Luna 2 impactor, which arrived on the moon. And then, on July 20th, 1969, humans, for the first time, landed on it. The landing place was Mare Tranquillitatis with the lander Eagle of the United States Apollo 11 mission. Since then, we have continued to explore this satellite, first with crewed missions and then robotically. Scientists have also been wondering about how it actually formed. And this is what we know. Billions of years ago, our planet in the first throes of its birth was a completely different world. The theory goes that the moon formed billions of years ago, not long after Earth's formation, from the debris thrown out by a giant impact between Earth and a Mars sized body called Theia. But how exactly this formation took place has remained a puzzle for decades. Most theories claim that the moon formed out of the debris of this collision, coalescing in orbit over months or years. But now we have a new theory and a new simulation that posits that the moon may have formed immediately, in a matter of hours, in fact, when material from Earth and Theia was launched directly into orbit after the impact. So, according to this new study, this opens up a whole new range of possible starting places for the moon's evolution. One thing scientists have always wondered about is why the composition of the moon is so similar to that of Earth. They have analyzed the composition of lunar material based on its isotopic signature, which is basically a chemical clue to how and where an object was created. This lunar material has been available ever since astronauts have brought back samples from the moon. According to NASA, the lunar samples scientists have been able to study in labs show very similar isotopic signatures to rock from Earth, unlike rocks from Mars or elsewhere in the solar system. This makes it likely that much of the material that makes up the moon originally came from Earth. Previous theories said that Theia sprayed out into orbit and mixed with a very small amount of material from Earth. This would be less likely because of the strong similarities we see in the composition of the two bodies, unless, of course, Theia was also isotopically similar to Earth, which is not very likely. Again, according to NASA, there have been theories proposed to explain these similarities in compositions, such as the synestia model, where the moon is formed inside a swirl of vaporized rock from the collision. But these arguably struggle to explain the moon's current orbit. Unquote. So, this really very fantastic new simulation puts forward a different theory where the moon may have formed immediately in a matter of hours when material from the Earth and Theia was launched directly into orbit after the impact. You can actually see the video on our YouTube channel 360 on History and also on the website 360onhistory.com. Go check it out. It's absolutely stunning. According to the statement by the researchers, this faster single-stage formation theory offers a cleaner and more elegant explanation for both these outstanding issues. It could also give new ways to find answers for other unsolved mysteries. This scenario can put the moon into a wide orbit with an interior that isn't fully molten, potentially explaining properties like the moon's tilted orbit and thin crust, making it one of the most enticing explanations for the moon's origins yet. Unquote. The scientists conclude, the more we learn about how the moon came to be, the more we discover about the evolution of our own Earth. Their histories are intertwined and could be echoed in the stories of other planets changed by similar or very different collisions. Once again, please go check out the simulation on our YouTube channel 360 on History or on the website 360onhistory.com. And thank you for joining me today, and I'll see you again next time.